All right, guys, today we are ready to start Unit 5. Unit 5 is all about operations with polynomials. Okay, or you could say polynomial operations. Either way, we're going to be doing adding and subtracting. Also, just talking about what we call these things, okay? And then we will be multiplying, and eventually we're going to get to dividing polynomials, which has a special name. Okay, so we're going to get through these 6 lessons on polynomial operations. So let's start with what is a polynomial. It is, and this should say expression, this is an expression with many terms. Okay, an expression with many terms. And so I tried to give us some examples here. A polynomial could just be an integer entirely on its own. It could have 2 terms in it. It could have 2 terms with multiple letters and variables. It could have 3 terms where the different variables have different exponents. Okay, polynomial functions could pretty much look like almost anything. All right. Um, Now, when we are writing our polynomials in standard form after we have simplified and added or subtracted or multiplied or done anything that we can do with them, when we simplify, we have to put them in standard form, which is alphabetical order with the highest exponent going first. Okay, so the proper name for this is descending order. Remember, descending is going down. Okay, so let's jump right in here with example number 1, and this is probably going to feel pretty familiar to you. All right. So it's kind of like combining like terms like we've done before, but then also rearranging and putting them in the right order. So in example number 1, I have a 3x, I have a 1, and I have a 2x squared. Are any of those like terms? And the answer is no, they're not. So in the past, I would just say, well, just leave it alone. There's nothing to do. Move on to the next problem. But here we need to put it in the proper order. So the highest exponent is 2x squared. So that has to come first. After that, I need to put the next smallest exponent, which would be 3x. Now that 3x is a positive, so be sure to bring that down. And then finally at the end, I have my constant. The constant is always going to go last because it is like x to the 0 power. Remember, x to the 0 power equals 1, and 1 times 1 is still 1. So that would be the least exponent that you could possibly have, is anything to the 0 power. All right, and so that is our work for number 1. Let's do number 2. So I'm going to always start by looking at these. I have k squared, I have a 64, I have a minus k, and then I have a 7k cubed. I have nothing that is the like terms to combine. So I need to start with the highest exponent and just write them in standard form. 7k cubed plus k squared minus k, and then finally in the back, I have my constant term. Remember, constant term is that number that's by itself. All right, so that is it. Here's what I want you to do. I want you to pause the video and try examples 3 and 4 on your own. Alrighty, welcome back. I have done number 3. Now notice I only underlined the positive 28 and the negative w because those are the only 2 terms that I had to kind of move around. The w cubed plus 5w squared was already in descending order, so I just had to fix up those last 2 terms. And then in number 4, I went ahead and underlined everything because everything kind of got shuffled around there a little bit. Okay. Alrighty. Let's take a look at number 5 together. Number 5 is a little different because I have an a cubed, but I also have a minus 2b cubed. So I have two exponents that are of equal order, but the terms are not the same. One's an a and one's a b. So here's what I do to prioritize a problem like this. I also need to focus on alphabetical order. So A comes before B. So A cubed will have to go in the front. Now, some people would like to put minus 2B cubed next, but that's not quite how it works. I need to keep my A terms going in descending order, and that is my primary focus. So the next under a cubed would be a squared. So I need to take that whole term, and that's what has to go second. I'm focused on my a's. So now I have a cubed, a squared. So a is going 3, 2. Where would my a value be? A 1? Right here. Let me just go ahead and use black to underline this. So a to the first power, so plus 2ab. So my a's are going down, 3, 2, 1. And then at the very end where there's no a's, I have this minus 2b cubed. And so my a values are in descending order. Notice that my b values are kind of working oddly backwards, okay? But that is okay. All right, focus on the first alphabetically correct letter. So I want you to go ahead and see if you can do number 6. Pause the video and give that a try while you rearrange those. Welcome back, and hopefully you were able to get number 6 all in the correct order. Notice that I did C comes before D, so I said C cubed, C squared. The next one did not have a C, but neither does the constant term. So I put the 5D cubed before the constant term because I always want that constant term to go very last. All right. All right, let's take a look at the names that we give to polynomials based on what degree they are, meaning what number exponent they have. If you think about like when we say it is 67 degrees outside, you know how we put that little degree symbol up there. Degrees. So when we're referring to what degree is a polynomial, we're going to be looking at what exponent they have up in that little same corner where the degree symbol would go. Okay, so that's kind of a good way to help you remember the degree of a polynomial. And then the number of terms that they have. So I kind of tried to highlight for you using red the different prefixes for nomials, okay? We have a monomial, which is one term. Remember, we already had that discussion about like monopoly. The goal is for one person to have monopolized the entire board. Another example would be a monopod. My husband has used those for photography purposes. It is similar to a tripod, except it only has one leg. So mono means one. Binomial, bi means two. So think of bicycle. I'm sure there's a lot more examples. I'm just running low on them right now. Okay. Tri would be tricycle, has 3 wheels. Triceratops has 3 horns. Okay. And then poly. The prefix poly means many. So anything that is a fourth, has 4 terms or more, we just call that a generic polynomial. Okay. Some people might say polynomial with 4 terms, but polynomial is just our generic. Okay. And then let's look at our degree. So if it has a 0 degree, it's called a constant. And I kind of showed you that earlier. If I just have the number 2, you could also have a x to the 0 power there with it, which is equal to 1. 2 times 1 is just 2. So it doesn't change the value. If it has an exponent of 1, this would be like 2x to the first power. That is called a linear function. Remember, our linear functions look like y equals mx plus b.
Attention all faculty and staff. I could please have your attention for a moment. Today I will have a video meeting at 2 o'clock. Hopefully I will have some information to share that I'll be able to answer some questions for you. Again, the video meeting today is at 2 o'clock for me. So plan to meet maybe 35, 40 minutes after that. Hopefully I will have some information that will answer most of your questions. Again, please be prepared to meet or at least listen to the comments and announcements or check your email around 2:45 or 3 o'clock. Thank you.
Okay. All right. A quadratic function, which we are going to be heading into our unit on quadratics soon, but it would look like 2x squared. Okay. Cubic would be, let's say, 6x to the cubed power, right? And quartic would be 4. So let's say x to the 4th power, okay, would be a quartic function. And that would be the highest exponent in the whole polynomial is when we are referring to the degree, it's only the highest exponent. So let's look at some examples down here. So number 7, what is the name of this function? Well, it is a number all by itself with no exponents. So this is going to be a constant. And then how many terms does it have? It has 1 term. So it's going to be a constant monomial. All right. I'm going to jump around a little bit. Let's look at number 12. Let's look at number 12. What is the highest exponent that you see in number 12? And the answer is this 4 here. So this is going to be a quartic. And now I need to look at how many terms does this have. So it has 1, 2, 3, 4 terms. So this is a quartic polynomial. Okay, and that's really all that I'm doing. I am identifying the largest exponent, and that is the degree, and I'm going to use these names here in blue. And then I look at how many terms do I have, and that is the second part of my name. It's always a 2-part name. So what I want you to do now is go ahead and pause your video and see if you can name the rest of these 4 examples on your own. All right, welcome back. I have gone ahead and named each of my polynomials here based on the degree and the number of terms. Okay, so number 8, the highest exponent there was 1, so it's linear, and there's only 1 term. Number 9 is also linear, but there are 2 terms. Number 3 had an exponent of 2, so that makes that a quadratic. And then it had 3 terms, so it's a trinomial. And then number 11 had an exponent of 3, which made it cubic. And there were 2 terms, so cubic binomial. Great job, everybody. So now that we know what to call these polynomials and how we order them the proper way, let's go start adding and subtracting with them. And this is going to feel really, really similar to what you guys were doing when you were just combining like terms with multiple parts, okay? So, whether or not, or whether you're adding or whether you're subtracting, both of these, you want to eliminate the parentheses by distributing. Okay, so whether it's a plus sign or a minus sign, remember there's a 1 there. There's a 1 there. And so I always want to distribute that 1 into the parentheses. So when I do that, positive 1 times all of these is not going to change the value of any of them. So 1 times 2x squared is still 2x squared. 1 times negative 23 and 1 times negative 5x. And then notice that there is nothing in front of this but a positive 1, so I'm going to bring this down. And the one thing that I did forget is that this is a positive 2x squared. All right, so once I have distributed that 1, then I'm ready to combine my like terms. I want to do the same thing for the subtraction example. Okay, I am going to distribute this negative 1. So it is negative 1 times 7x. It is negative 7x. Negative 1 times 3 is negative 3, and that's x squared. Negative 1 times 1 is negative 1. And I'm going to bring down what was up here in front of it. Okay. So the biggest difference between addition and subtraction. Addition, when you distribute the positive 1, it does not change the values of the numbers that are inside the parenthesis. But when you distribute a negative 1, it does change the value. Negative 1 changes the value of everything inside the parenthesis. Okay? All right. So, even though that happens, just know that step number 1 is exactly the same for adding and subtracting. Nothing is different. Okay? So that is going to be our step number 1. And I'm going to make a little note of our steps out to the side. So step number 1, distribute plus 1 or the negative 1. Okay? Step number 2 is going to be to combine all of your like terms. And step 3 is going to be to put them in order, in proper order. Put in proper order, okay? So let's do step 2 now. I have a 2x squared, so I can combine my like terms and put them in the proper order at the same time. And that's what I'm going to be doing here. So I look at this and I find the biggest exponent, which is a 2. And so there's nothing to combine it with. So I'm going to bring that right to the front. Next, I'm going to find, whoops, I was wrong. There was something to add that to, wasn't there? There's another minus x squared right there. So 2x squared minus 1x squared is just 1x squared. So be careful when you're looking at this. It can be easy to kind of overlook some things sometimes. All right, next is x's. So I have 11x's minus 5x's, which is going to be a positive 6x. And then finally, I have my constant terms, positive 13 minus 23, which gives me a minus 10. All right, let's do our subtracting example. We're going to do steps 2 and 3 at the same time. So I am going to find the largest exponent. So that is 4x squared and then minus 3x squared, which gives me a 1x squared. My next highest exponents That is a 5x minus a 7x, which is negative 2x. And then I have this minus 1 out at the end, and there's nothing to combine it with, so I just bring it on down. All right. So I really do feel like, based on our previous lessons with distributive property, combining like terms, um, and our little discussion today on putting things in descending order, that you should be able to do these examples pretty easily on your own. So what I want you to do is to pause your video, and I want you to complete examples 13, or practice problems 13 through 18. All right, be sure to put all your answers in the descending order. So 13 through 18. All right, so I have completed examples 19 through 24, and every single one of these 6 examples was subtraction. All right. Remember, the subtraction can be dealt with the exact same way that the addition is. We just need to always remember to distribute whatever that 1 is outside of the parentheses, whether it's a positive 1 or a minus 1, we need to distribute it. All right. And now let's look at some translation problems. I mean, they're not really word problems, but number 25, they want me to find the sum of these. So what I would just do is start combining like terms, because I'm going to add them, right? So 8p squared minus 2p squared is 6p squared. Negative 2p and nothing else is just negative 2p. And then finally, I have 15 plus 11, which is 26, minus 1, which is 25. And that's it. Let's look at number 26, and then we're going to be finished for this lesson. So they want me to take this and subtract it away from this other one. So here's how I'm going to write that. I am going to say minus parenthesis 2w squared minus 5w plus 10. So I now put it in the correct place. And now I'm ready to do my distributing. Remember, that's a negative 1, so negative 2w squared plus 5w minus 10. And now I'm going to combine my like terms. So once I've simplified this, I am really not using any part of this anymore. So I've got w cubed. I have got w squares, and that's going to give me 4 of them. Next, I've got a negative, I've got a 5w, nothing to combine that with. And then I've got a negative 2 and a negative 10, which is negative 12. And that's my final answer. Great job today, guys. There is an assignment posted for you so that you can get some practice. And go ahead and get that done. There are an unlimited number of tries for you with your homework now that you are home for a little while. So just keep trying. Don't give up on yourself. Don't give up on the math that I'm going to still be teaching you. It is going to be kind of difficult, but know that you can always still text me on Remind. You can email me. You can post questions in Google Classroom. For myself or from your classmates, they can also help you. So let's just keep working together so that we can try to get through the rest of this school year. All right, guys? All right, until next time.